the session of software engineering. So myself, Professor Hemant SR, Department of CSE. So this subject is also being handled by Professor Shweta Shetty from ISE department and Professor Kravya Priya from CSE. So I will be handling this subject along with them. Okay. So module 1 was completed by Professor Shweta Shetty. So we will just have a recap of what you had studied in module 1. The reason being, you need to have a continuity between module 1 and module 2. So what you had seen in module 1 will be described in a nutshell, and a link will be created to module 2 and a brief introduction about module 2 will be given. Okay. Now, what you had seen in module 1, what are the different aspects of software engineering you had seen in module 1. Okay. So in module 1 you started with what is a software, okay, what are the principles and practices of software engineering that is used to develop a software. So this is what we had seen in module 1. Okay. So to have a recap of it, we saw what is a software. So software is a collection of instructions. Okay. So we have a set of instruction. Basically software is a program. From this program you are expecting some functionality. You want some functionality from this program. For example, if this is a program of addition, adding two numbers, so you are giving two numbers to this program as input. What you are expecting from this program or from this software? You are expecting this program to add these two numbers. So it should add these two numbers, for example 2 plus 3, and you should get the output, that is 5. So this is what you are expecting from a program which is a software. Okay. Now what is there inside a program using which you could achieve this? There are some set of instructions. We have instructions here. So instructions are there, line number 1, 2, 3, 4, maybe up to line number 10. See, this was a simple program, simple example of adding two numbers where there were 10 instructions. Okay. This is also a software. Now, do I need software engineering to develop this program? Do I need software engineering for developing a program to add two numbers? So the answer to this question is no. The reason is the complexity of this program. Okay. Now, how is the complexity of this program? How we measure the complexity of the program? See, complexity is measured by using what is called as LOC, or lines of code. Okay. Now, if you just give a glance of this example, you can see 10 lines of codes are there. So 10 lines of instructions are there, starting from 1 to 10. So the complexity of this program is 10 lines of code. Now, so totally 10 lines are there. Now can I classify this program as a simple program or a complex program? That is a question here, and the answer to this question is, so it is simple. The complexity is, it's a simple program or simple software. Now when you can claim a program to be complex, say if it is more than maybe 1000 lines or 10,000 lines of code, so then obviously it's a complex program, okay, complex software. Now why this complexity was taken into consideration or discussion? The agenda here is where you need software engineering. Do I need software engineering principles if the program is simple? Okay, the answer to this question is no. You do not need software engineering principles and practice if the program is simple. What if it is complex? What if the software is complex? Meaning that the number of lines of code is greater than 1000 or 10,000, maybe 1 lakh, 2 lakh, 50 lakh, millions, billions. Okay. In that case, we need a systematic way, strategic way of developing the program. Okay. We cannot do it in a random fashion, we cannot do it in a ad hoc fashion. So definitely we need a systematic way of developing the software which is complex, and there comes software engineering. Okay. The bottom line here is, if you are developing a software, if you are developing a program, okay, software which is complex, okay, what is complex software? Already it has been indicated, thousands of lines of codes are there, okay, thousands of lines of code, okay. If you are developing such a software or a system, so you need software engineering, okay. Now I'll abbreviate it as SE. Now how software engineering can help me achieve my objective, okay. So when something is complex, okay, we need a way of doing it in a systematic fashion, and that is what software engineering is about. I want to develop this software with thousands of lines of code. Let me do it in a systematic fashion. Let me do it systematically. Let me do it in an organized way. Let me do it in a more structured way. And that is all about software engineering. Software engineering has the principles and practices to develop a complex software in a more systematic, organized, strategic way. Okay. Now what will be the benefit of this? The benefit of this is you can complete the software within the schedule, within the deadline, within the estimated cost, and you can deliver it to the client. So that is the importance of software engineering. So in a nutshell, software engineering, principles and practices of software engineering is used if the software is complex. If you are developing a simple software, simple program, you do not require software engineering principles. It is not needed. Okay. So that was the first point. So you are developing a software. You are developing a software. There is a starting point and there is an end point. Okay. So from the starting point to the end point, so whatever steps you are taking, whatever procedures you are following, okay, so we call it as a software process. So it is called as a software process. What steps you are taking, how you start, how you progress, okay, what are the different milestones, okay, and how you end. So it is software process. That was one of the topic in module 1. Now in software process you studied different models, okay, how you can progress in this fashion. So you started with the waterfall model, where we saw the step is in sequence. Okay, you collect the requirement. Step 1, you collect the requirement from the client. Step 2, from this requirement you come out with the design. Step 3, from the after the design it is implementation. Once done with the implementation, then you will enter into testing, and once you complete testing, it is maintenance. Okay. This was one of the models. Okay. So that is a waterfall model that you had studied in module 1. Many drawbacks, many limitations were highlighted, because of which we came out with the next model, that is the incremental model. Okay. So what exactly happens in incremental model? So we do not go in sequence. Okay. So with whatever requirements we are having, for example, have some set of requirements, and please note it is not complete. It is not complete. So in incremental model, have some requirements. Using this requirement, I will design, implement, and test the product. I will come out with increment 1. Okay. So increment 1, a small increment. After completing with increment 1, please note I have a prototype, working prototype, because I have implemented it. By seeing this prototype, I will derive some more requirements for the system. Okay, some more requirements. Okay, I will call it as requirement set 2. Let this be requirement set 1, just for understanding purpose. I have some more requirements. Okay. So using this requirement, I will develop the next increment, increment 2. So then increment 3, increment 4, please observe, please note, we are not going in a sequential way, or we are not going in a serial fashion in incremental model. Instead, we are developing small increments at a time based on our understanding of the requirement at that point of time. Okay, it is slowly helping us evolve. Okay, so this was the second model. The third one was the spiral model. This is one of the popular models that we experience. One of the highlighting features of this module, is this model we saw in module 1 was the rigorous testing. So one of the highlighting features of spiral model is risk analysis. Okay, in each and every stage of software requirement collection, design, implementation, testing, we try to figure out what may be the risk involved and we try to mitigate the risk. So that is a specialty of spiral model. So different models we had seen in software process. Okay, various models we experienced. So this was the thing. Next, we understood the requirement engineering. So what is requirement engineering? Okay. Consider an example. MIT College Library wants a software to manage its library system. Okay. Now MIT College Library will become the client, and the college needs to approach a software company for that specific software. So the software company will have a discussion with the stakeholders. In my example, it is a library person who is involved with various activities related to the library. Okay, so they will try to understand what features and functions they want in the software. Okay, so that is done using what is called as requirement engineering. What the client wants, what features, what functions the client wants in their software. Okay, so that is collected, documented, and this document is also formatted in the form of what is called as SRS that you had seen in module 1, the software requirement specification. So SRS is a document that contains the requirements of the client, what the client wants, what the client needs. So all these things have been meticulously documented here. Okay. So these are the three parts that you saw in module 1. Module 1 started with introduction to software engineering. What is software engineering? When you will be using the principles and practices of software engineering, when it is not required. It is not like you are developing a software and you should use software engineering principles and practices. That is not the case. Software engineering principles and practice you will use if the software is complex. Okay, so that is what boils down in the first section of module 1. In the second section, we saw what is a software process. To develop a software, which is a complex software, obviously, there should be a process. Process means there should be a starting point, there is a sequence of steps, and there is an end point. Okay. How to do it? For realizing this, we have various models starting from waterfall model. Okay. Then the incremental model and the spiral model. That was the second aspect in module 1, and the third aspect in module 1 was requirement engineering. We understood before developing a software, the fundamental aspect that is required is collect the requirements from the client. What the client wants, what exactly they are expecting in the software, what features they want, what functions they want. have a discussion with the client, sit down with the client, have a discussion, collect it, document it, and we have a SRS called as Software Requirement Specification. Okay. So this is what we saw in module 1. So in the last few minutes, whatever discussion was done was related to what was there in module 1. Now what is the reason for taking up this? Okay. Did I take up this randomly? Definitely not. There is a link between module 1 and module 2. So what is that link? That needs to be established for better understanding and clarity of module 2. Okay. What is that we will see? So in module 1, this is what you saw. This is our module 1. Module 1, you understood how to interact with the client, how to collect the requirements of the client, and once the requirements are collected, how to systematically document it. So you need to document the requirements in a systematic fashion, which is also called as SRS, Software Requirement Specification. So Software Requirement Specification. So this is a detailed documentation of client's requirement. This is where we had stopped in module 1. Okay, this was our module 1. Yes, this is the stopping point of module 1. Now once we are done with this, what is the next thing? What is the next step? What should happen next? Now if your guess is start directly developing the system, or to put it in a layman's language, or to put it in a simple language, start the coding for this, start coding, hard coding the software for these requirements, and install the system. If this is your answer, it is wrong. The answer is wrong, meaning that once you have the SRS in place, you are not directly starting with the coding. Okay. Then what you are doing? What is that step in between that is filling the gap? Okay. So we'll go through that. So now I have my SRS. Software Requirement Specification. So already I made a claim. SRS is not taking a transition into coding. It is not directly being taken into coding. Okay. We have one more intermediary step here called as design. Okay. Design. Okay. In design, we have a planning about the system. We do a meticulous planning about how the system should be. Okay. So how the system should be. So we do planning about it in this stage. Meticulous planning, detailed planning. We also plan about what are the different modules, what are the different subsystems, modules that needs to be present. Okay. We also plan about how these subsystems and modules should interact with one another. Okay. All these things are meticulously planned, and a blueprint is created. Okay. A blueprint is created. Complete planning is done, a blueprint is created, and once you are ready with the blueprint, then you enter into the next step, the next stage, that is coding or implementation. So you enter into coding or implementation. Okay. In coding or implementation, you will use different programming languages. So use programming languages. What do you do using the programming languages? See, whatever design you have completed, okay, so you create a hard code for it. You create a code for it, okay, using programming languages. Example of different programming languages you have already seen, starting from C, C++, Java, Python, Perl, PHP. Okay. So you come out with a working model, you come out with a deployable model in this case. Okay. Once you are done with coding and implementation, then you go with the testing. Okay. You go with testing of the system. What exactly you are doing in testing? So in testing, you try to determine any flaws, errors that are there in the software. Also, we try to validate the software. What exactly is validation? Validation is you will check whether all the requirements given by the client. Please note, all the requirements are documented in SRS. All the requirements given by the client is present in the implementation. Okay, that is validation that you are doing here. Okay, so this stuff, that is coding and testing. So you will study in module 3. So this is a story of module 3. Okay, so how exactly you can come out with the implementation plans, how exactly you can do the testing part. Okay, so all these stuff you will study in module 3, module 4. Okay, also how exactly you can do the complete planning starting from this point to the last point. Okay, so after testing you enter into maintenance. Okay, so you go with the maintenance. What exactly is maintenance? See, maintenance is after you complete the testing, now you have a software which is working with minimized errors and bugs. So you cannot remove 100% of the errors or bugs in a software. Okay. Now you give the software to the client. For example, I have taken an example where a software was being developed for a MIT library. Okay. So the company has developed the software, it will give back the software to our library. The library personnel, they will start using the software, and while using the software, they may experience some issues, some errors, some flaws. Okay, and that will be resolved in the maintenance phase. That is one thing. So in maintenance, any errors that pop up when using the software by the client will be resolved. Also, updation. Okay. So as we know, technology is continuously changing. The needs of the society is continuously changing. Okay. So as the needs of the society or customer changes, you need to update the software. What do you mean by updating? Adding new functions, new features to the software. Okay. So all this is part of maintenance. So all this stuff you will study in module 3, 4 and 5. So this was the big picture of software engineering in the context of your syllabus that you have as prescribed by VTU. Now you completed with this part. This was completed in module 1. You understood how exactly, where exactly software engineering is needed, where it is not needed. You understood the starting stages of developing a software. You understood it is collecting the requirements from the client and documenting it. Okay, so we have completed with this part. We also understood once we have the requirement, we do not directly jump into coding. Okay, there is one more very important step, very important stage, so called as design. Okay, so we will focus on this in module 2. Okay, so this is where your module 2 is coming into picture, the design aspects. Okay. Now how to do the design? Okay. Different ways of doing design are existing, and one of the popular ways that is widely accepted across the globe is object-oriented design. Okay, so object-oriented design is one of the design techniques which is commonly adapted and used by all the software companies across the globe. Now, is it randomly chosen, or is there some solid reason, strong reason behind this? Okay, so there is a reason for this, why this object-oriented design is chosen. And you can see that title of your module 2, so object-oriented modeling. Okay, so why object-oriented design has been chosen by software companies to come out with the design details? What is the reason? So many reasons are there, some of which I will highlight here. One of the reason is object oriented design is flexible. What do you mean by flexibility? You can stretch it, you can compress it to any extent you want. Okay, you can expand the system. Okay, you can make changes to different parts of the system, okay, in a more convenient way. That is flexibility here. Okay. Adaptable. Okay, you have a software system, I'll call it as system 1. This is system 2, and if both the systems are object oriented, they can easily interact with one another, adapt with one another, okay, function in a synchronized way. Okay, so that is one part. And the third important reason why object oriented design is it's popular. The reason is what you are seeing here on the board. These programming languages. Please note, what is common among C++, Java, Python, Perl, PHP? Still the list goes on. Ruby. Okay, so the .NET framework. What is common among all the things? The common thing that you can identify among all these programming languages is all the programming languages are object oriented. Okay, they are object oriented programming languages. Now what is the benefit of this? See, the language, the programming language using which you are doing the coding itself is object oriented. Now if we come out with a design which is object oriented, now do you think there is some obvious benefit? Definitely there is natural advantage here. What is that? Easy transition of design to coding, that's it. Okay, so when you are converting this design, okay, see, ultimately you need to convert this design into a code. You need to convert it into a code. Okay, see, if the design is object oriented, okay, converting it into a code will be simple, will be easy. Okay, so that is easy transition to coding. So I am repeating once again, we are into the design aspect. Okay, design is between the requirement and coding. Design is a very important stage in developing a software, and for designing a software, one of the popular approaches across the globe is using object oriented design. Few reasons were discussed. Okay, so why it is popular, why it is advantageous. Okay, and the highlighting feature is you come out with a design using object oriented modeling, and you can easily go with the coding or implementation. Okay, so that was the part. So in a nutshell, module 2 is talking about design, and to be more specific, it is object oriented design. So module 2 is talking about design which is object oriented. Okay, now how exactly it is done, how exactly it happens. Okay, so steps or stages you will see. Okay, so first we have the SRS. Already this was specified. So SRS is the starting point. Okay, starting stage in object oriented modeling. We need to have the SRS. Why SRS? So all the requirements of the clients are there here. So you should understand what the client wants, then only you can start developing the, start designing and developing the software or system. Okay, so you take this SRS and you do what is called as object oriented analysis. So we do what is called as object oriented analysis. What is object oriented analysis? Okay, object oriented analysis is identify the objects in the SRS. So identify the real world objects in SRS. Okay, please note the previous step is SRS. In the SRS, try to identify the real world objects. I'll give you an example using which you can achieve more clarity. Okay, identify the real world objects and classify the object. Classify. This is what we call as object oriented analysis. Once you are done with this, then we come out with this is even represented in short form OO. Object oriented is abbreviated as OO. Once done with this, so we have OO design. What exactly we are doing in this? See, whatever real world objects we have identified and classified, we represent this using graphical models. Graphical models. Okay, this is what is happening in object oriented design. This is what is happening in object oriented analysis. And your complete module 2 is having a detailed discussion about these aspects. How exactly to do object oriented analysis and design. Okay, that is what you have as part of module 2. Okay. Now this was at an abstract level. A general terminology was used, and without an example, I'm sure things will not reach you. You will not be able to understand this. So now I will go to take an example. So one of the example that you have already seen in module 1, that is the hospital management system. So hospital, so management system. So now consider a hospital wants this software, hospital management system. Why it wants this software? Consider any hospital, it may be Apollo Hospital, Columbia, ISE. Okay. They need a software to automate all the process that is being done manually. For example, patient booking an appointment with a doctor, doctor going through the medical details of the patient and updating the data in the database. Okay. And making salary of employees who are working in that hospital. See, all these things that were being done manually, which was a tedious job. So each and every hospital wants to automate it. Okay, so that the process is conducted in an efficient and effective way. Okay, so for which they need a software system. When they need a system, okay, or a software. Okay. Now, if Columbia Asia wants a hospital management system, they will approach a software company. For example, they may approach a TCS and they may put forward a request that they need a software to manage all the operations in their hospital. Okay. As already mentioned, TCS now will visit Columbia Asia and they will have a discussion regarding what exactly they are expecting from the software, what features, what functions, okay, how they want the software to be. Okay. They will collect everything and they will have a documentation of it, which is called as SRS, Software Requirement Specification. Okay. Once done with it, okay, already I told you the next step is design. Basically it is design. Now how exactly design is done? So the steps or stages have been indicated here. First one is analysis. In analysis, what they are doing? Identify the real world objects. Okay, please highlight this term. Identify the real world objects in SRS. Now for a hospital management system, what are the real world objects? What can be a real world object? Okay. So real world objects can be, for example, doctor, okay, staff who are working in the hospital, it may be patients in the hospital, they are the real world objects, okay, or entities, we even call it as entities, What are the other entities that may be present in a hospital? Say a hospital may have an ambulance facility may be there. Okay, so doctors or patients or staff coming to the hospital may have a two-wheeler or four-wheeler. Okay, they may have a car, they may have a two-wheeler. Okay, what are the other entities that may be present in a hospital which is real world, which is having physical existence? So the other entities may be, for example, tablets, syrup. See, these are the different entities or real world objects, okay, so that may be present in a hospital context or an environment, and definitely during object oriented analysis, the designers of the system will encounter with these entities. Okay, I have given few examples. Okay, so that was the first step, identify real world objects in SRS. A few have been done, a few have been listed here, you can see this. Once done with this, completed with identifying the real world objects, the next step is you need to classify the objects, you need to group the objects. How you classify or group the objects? You should do the classification in such a way that these objects or objects which are closely related come under one common group, that's it. For example, if you just do some simple analysis, you can make out doctor, staff and patient, okay, they can come under one group. Okay, so this can be one group, I'll call it as group 1. Okay, so ambulance, car and two-wheeler, okay, so they can be group 2. Tablet and syrup, it can be group 3. What is your observation here? Once the real world objects were identified in the SRS, they were classified, they were grouped. Classification is nothing but creating groups. How the groups have been done? The groups have been done in such a way that the objects are closely related to one another. Okay. For example, doctor, patient, staff, they are closely related. Ambulance, two-wheeler, car, they are closely related. Tablet, syrup, once again they are closely related. Okay. So this is what we call as classification. Okay. Now anyhow, since we are at this part, I'll just brief you regarding what is a class and object. I think this can be a perfect platform or starting point to understand what is a class and what is an object. Okay. Now take up group 1. Take up group 1. What is group 1? Doctor, patient and staff. Okay. So what is the common thing that you notice between all the entities in group 1? The common thing is they are all human beings, they are all persons. Okay. So I will call it as class person. Okay. So my group 1 now is becoming class person. Okay. Now do they have some attributes which are common? Okay. So it may be a doctor, it may be a staff or a patient. Few things will be common to them. What is it? They will have a name, they will have an age, they will have some designation, or I'll call it as a capacity. Okay. So few things are common to all the entities in the group, and that is what we call as attributes. Okay. Attributes of a class. Okay. Next, there are few things that can be done by all these entities. For example, it may be a doctor, staff or a patient. Some things are there that can be commonly done by all the three, like they can maybe walk, they can run. Okay. So this we call as operations. So what exactly is happening here? Once we identify the real world entities and group it as a class, we are identifying the attributes and operations, okay, and creating a common junction, common platform for them. So this is the class here. Now what is the benefit of creating a class? Okay, how it will help us in design? See, one of the powerful features of having a class oriented design is you can create n number of objects or instances for this class. For example, you can create 20, 30, 100 doctors, okay, using this class. You can create hundreds of staff, patients for this class, the details of which you will see in later part of module 2. Okay. So this is what you will study in module 2. In module 2, the major emphasis is on design. Okay. Once you have collected the requirements from the client, we are not directly going into the coding part. There is an intermediary stage called as a design, where you are coming out with a blueprint, a plan for how you want to develop the system. Okay. Now, how you develop that plan, how you come out with that blueprint, there are different ways of doing it, and one of the popular ways is object-oriented design, object-oriented modeling. Okay. What exactly you are doing in object-oriented modeling? Okay. A series, we saw a few steps, the detailing of which you will see in different sections of module 2. Okay. So the highlighting feature here is object-oriented modeling starts with identifying the entities in the SRS. Okay. What are the different entities that are present in the software requirement specification? So that will be the starting stage. And once you identify the entities, for example, as you are seeing here, in the hospital management software, doctors, staff, patients are the entities. Even ambulance, car, two-wheeler can be the entities. Once you are clear with the entities related to the software as specified in SRS, you do the required classification, you do the required grouping. Okay. And groups which have many things in common. Okay. For example, doctor, staff, patient. Okay. It is one group which has few things in common, few attributes which are related. We will push them into one class, maybe person. If you see group 2, you just go through group 2. So in group 2, if you observe, it is ambulance, two-wheeler and car. Okay. I can maybe call it as class vehicle. I'll call it as class vehicle. Now what are the things that are common between maybe ambulance, two-wheeler and car? Okay. It may be ambulance, two-wheeler or car. It will have a name. It will have a model associated with it. It will have a color. Okay. Please note, it may be an ambulance, it may be a car. So these things you will find in common. Also, what are the operations that you can associate it with this particular class vehicle? Okay. So the operations can include move forward, so left, right. Okay. So the bottom line here is, from the SRS you identify the entities. Once you identify the entities, group it in such a way that similar entities come under one group, and once you are done with this, you have completed the class. Okay. How exactly it is done, the detailing of which you will see in different sections of module 2. So once you complete with this, the next part is modeling. Okay. So over modeling, what do you do in over modeling? Okay. See, we have different classes, class, maybe person, class, So we have class person, class vehicle, how they are related to one another. Okay. How class person maybe is related to class vehicle, how class person is communicating with this class. How they are related, how they are communicating. Okay. Also, you may create objects for these classes. Okay, you create different objects, the details of which we will see later. How to create an object, how to model an object, we will see that. How these objects are related. Okay, how they are communicating. So all these things we represent using standard models like class model, interaction model, state transition model, so this is a section in module 2 where you will see how classes and objects are related and how they are communicating. So it is represented using different models. Okay, so that is one section in module 2. Also you will see few powerful features of object oriented design called as abstraction encapsulation. Once again, the details of which we will take it up in the later sessions. So in this session we had a brief recap of module 1. There was a strong reason behind this. The reason was there is connectivity between module 1 and module 2. So we need to have a recap of what is there in module 1. We understood module 1 is all about identifying where exactly software engineering is needed, where it is not needed. Also we understood how we should start with the process of developing a software. So we understood it is through collecting the requirements of the client. Once the requirements are collected, document it in a systematic fashion called as SRS. Okay, so that was your module 1. Now once you are done with SRS, we directly do not start with coding. So we have a very significant stage called as design, where we have a detailed planning of how to develop the software or system. We come out with the blueprint. We are not doing the coding here. Okay. Also we understood to come out with a design, one of the best ways and one of the popular ways accepted across the globe is object oriented modeling. Okay. We explored different reasons why it is so popular, why it is so acceptable. Okay. So that is what we saw. Also we understood how exactly object oriented modeling goes with software engineering principles. We understood what are the different stages in object oriented modeling. So it started with object oriented analysis, where we identified the entities and relation between the entities. We classified the entities. Then we went into the design part. So this was a brief overview of module 2 and how module 2 is interlinked or related to module 1. Okay, there is something carried from module 1 which will continue in module 2 with more detailing. So that is what was introduced in this session. So thank you.